Hello guys, my name is Isa Khaldi and today I'm going to explain to you these 4 slides. So starting from slide 18, uh, we have the types of wind turbine generators. So as you can see, we have 1 blade, 2 blades, 3 blades, multi-blades. So which one is better? What do you think? Let's find out. Let's go to the advantages of 1 blade. It can have a lower material cost due to fewer blades, simpler design leading to potentially lower maintenance cost. These are the advantages, but the disadvantages of it are significant imbalance issues requiring complex counterweights, reduced efficiency as compared to turbines with more blades, higher noise levels and vibration. Let's move on to the next one, 2 blades. The advantages are lower material and manufacturing costs than 3 blade turbines, easier transportation and installation. The disadvantages are suffer from dynamic imbalance, more prone to wear and tear due to higher rotational speeds, slightly less efficient than 3 blade turbines, especially at capturing lower wind speeds. The 3 turbine blades advantages are higher efficiency in energy capture due to better aerodynamics. Balanced load distribution reduces mechanical stress, lower noise and vibration levels. The disadvantages are higher initial cost due to more materials and complexity, more difficult to transport and install due to size. The multi-blade turbines advantages: excellent at capturing wind at low speeds, high torque which can be beneficial for certain applications like water pumping. The disadvantages are lower rotational speed leading to reduced efficiency for electricity generation, higher material and maintenance costs, more complex design and heavier structure. But in my opinion, for most modern wind energy applications, 3 blades turbines are the best option due to their balance of efficiency, stability and noise levels. So I would go with 3 blades. Now let's talk about yaw control mechanisms. So we have here 4 types again. Let's start with the upwind passive yaw with tail vane. The advantages of it are simple and cost effective, self-adjusting to wind direction without complex control systems. The disadvantages are less precise control, especially in turbulent wind conditions, and also potential for increased wear and tear due to constant adjustment. The upwind passive yaw with fan tail advantages: more precise than tail vane in aligning with wind direction, improved performance in variable wind conditions. But the disadvantages are more complex than tail vane, potentially higher maintenance, slightly higher initial cost. The upwind active yaw advantages: highly precise control over turbine orientation, optimized energy capture by continuously aligning with the wind, better performance in diverse wind conditions. The disadvantages of it are higher complexity and cost, requires more maintenance and sophisticated control systems. The last one is the downwind passive yaw with coning. The advantages are the blades can flex to reduce stress in high winds, reduced need for yaw control mechanisms as turbine naturally aligns with wind. The disadvantages are potential for tower shadow effect, reducing efficiency. Uh, Noise issues due to blades passing through the tower wake. Less common and thus less industry support and development. So, if you ask me which one to choose, uh, I would go with the upwind active yaw control. It's the best option. Modern wind turbines due to its precision and efficiency in optimizing energy capture. It's most widely used in systems in commercial winds, so I would go with it. Okay, guys, let's move on to the vertical axis wind turbines. So here again, but we have here 5 types of vertical axis wind turbines. Let's starting with each vertical axis wind turbine. It has like some advantages like simple design with straight blades, making it easier and cheaper to manufacture. Good efficiency at moderate wind speeds, easier to scale up for larger installations. But the disadvantages are structural challenges due to bending stress on the long blades, lower starting torque, often requiring external assistance to start. The Delta One is a stable and robust design due to support structure, the triangular support structure, good performance, enhance structural integrity, and reduces maintenance needs. The disadvantages are more complex and costly to manufacture than each vertical axis wind turbine. Heavier, which can complicate installation and increase costs. The diamond wind turbine, efficient in capturing wind from various directions, balanced structure which reduces stress on the turbine, and are like complexity in design and manufacturing, potentially higher maintenance requirements due to more moving parts. The Y wind turbine is like has some advantages like efficient in varying wind directions, easier to design. The disadvantages are lower efficiency compared to each vertical axis wind turbine, potentially higher material cost due to complex structure. The phi or the helical has also some advantages like lower noise levels and reduced vibration, self-starting capability at lower wind speeds. The disadvantages are more complex and expensive to manufacture due to curved blades, higher weight, and potential for increased maintenance needs. Now, orientation of wind turbine. Wind turbines are categorized into like two main overreaching classes based on the orientation of the rotor. Here we have the horizontal axis wind turbine. The characteristics of it are the rotor shaft is horizontally oriented parallel to the ground. The most common design features 3 blades, although 2 blade and multi-blade variants exist. Typically, the rotor is mounted on top of a tall tower to capture wind at higher elevations. The characteristics of VAWT, vertical axis wind turbines, are the rotor shaft is vertically oriented, perpendicular to the ground. Common designs include Darius and helical configurations, typically mounted closer to the ground, suitable for varied wind conditions. So I just explained the characteristics of each one. Of course, each one has its uses. So, for example, here, for example, the vertical axis has some advantages. Or let's first start with the horizontal axis. The horizontal axis advantages, like efficiency, is more efficient than vertical axis, especially in areas with steady, strong winds. Three-blade horizontal axis wind turbines are particularly effective at converting wind energy into electricity. The advantages of vertical axis, that it doesn't need to be oriented into the wind, simplifying design and eliminating the need for a yaw mechanism. So it's up to you. Each one has its own characteristics, advantages. You can use it where you can actually, the horizontal axis wind turbines are generally preferred choice for large-scale wind farms and commercial power generation due to their higher efficiency and technology. They are best suited for areas with consistent strong winds, but the vertical ones are chosen for smaller scale applications and areas with turbulent or variable winds. So I hope you enjoyed this page. I'm going to move to the last page, which is vertical axis turbines. Here also there are more advantages. I didn't explain them. Surprisingly, I didn't know that it will have some advantages and disadvantages in this page. Anyway, the advantages of vertical axis turbines are omnidirectional, accepts wind from any angle. Components can be mounted at ground level, ease of service. Lighter weight towers can theoretically use less materials to capture the same amount of wind. The disadvantages are the rotors generally near ground where wind poorer. Centrifugal force stresses blades and components. Poor self-starting capabilities, requires support at top of turbine rotor. Requires entire rotor to be removed to replace bearings. Overall, poor performance and reliability, less efficient. Here we are talking about the vertical axis turbine. And it also have never been commercially successful. So yeah, so I'm not going to explain more details because here where I should stop. So thank you for watching. See you in the next video.